Hello, geometry. So, in the process of solving to make sure something is a parallelogram or quadrilateral, you may find yourselves having to solve a quadratic equation, which means we thought you should have a little bit of an algebra review on how to factor, different factoring techniques, and of course the quadratic formula, which will sometimes be needed. So we're going to start off with, if you can factor, that's the way to go. And everybody has different factoring techniques, so feel free to rely on whatever techniques you learned in Algebra 1. If you are factoring a basic quadrilateral, like in this first example, where, again, usually we have ax squared minus bx plus c, and a, in this case, is 1, these are a little bit easier. What you're looking for is what will make this last term, what we multiply, what are the factors of 12 that add up to the middle term, -8. And so let's see, what times what? So if I had a -6 and a -2, that would add up to a -8, but multiply to a +12. Since that works, those are the numbers that go into my parenthesis. That's the P and the Q from up above. So we have x minus 6, x minus 2 equals 0. And then you set each factor equal to 0. So that means that x will equal 6. And here we have x minus 2 equals 0. So x will also equal 2. And that would be your answer. Now, if the equation comes to you and it's not set equal to 0, that is the very first thing you should do. So we're going to rewrite this as x squared minus x, subtract 6 from both sides. So we have it set equal to 0. A is still 1, so I just have to worry about the last term as a -6. This is a -1. So we want to think about what times what is a -6, so factors of 6. So it turns out that if I have a -3 and a +2, that would add up to a -1, multiply to a -6, so that gives me x minus 3, x plus 2 equals 0, and then we set each one of these equal to 0, so we get our two answers, 3 and -2, which you can always plug back in to check that they work. Now in this third example, notice that I have a not equal to 1, but here is where you want to, if you ever notice, factor out a greatest common factor first. So I'm going to factor out here a -2. That leaves me with x squared minus 12x. You can always do a quick -2 times a -12 is a +24. And dividing 70 by -2 gives me a +35, still set equal to 0. So we're going to factor this. We want something that multiplies to 35 but adds to a -12. Okay, so this will probably, let's see, 35, 7, and 5. So if we have a -7 and a -5, that would add up to -12, multiplies to 35. So we then can factor this, x minus 7, x minus 5. This -2 in front doesn't really do anything. We could even divide it away. So we set each factor equal to 0, and you get your answer of 7 and 5. As the two possible answers. Okay, now what traditionally gets harder is when a does not equal 1. Now here's where some people just do guess and check, some people have their little strategies. I have something I call the double rainbow. You may or may not like it. You can also turn this into factor by grouping, do the diamond box method. There's so many different strategies out there. So the one thing that differs from what I've been doing is when I do my little crosshairs here, here's A, here's B, here's C. What goes on top is no longer just c, since a doesn't equal 1, it's a times c. So this is going to be 12, because that's a times c. 13 stays here again. And then what times what is 12, but adds up to 13? That would be 12 and 1. However, those are not necessarily the numbers that go into your parenthesis, because a here is 4. My first term is 4x squared. So we know that this is either 4x and x or 2x and x. I happen to know it's going to be 4x and x because of my method. 4, this first term goes into 12. So that's why I know that the 4 will be there. Then I do this thing called double rainbow. Because remember, when you multiply this out, you're doing first, outer, inner, last. The two middle terms, that's your OI. The outer term, the 4x and what's going to go there, is that first and the last. And that has to multiply to 12. The other one to 1. So these numbers go on the rainbow, the double rainbow. 4 times what is a positive 12? That's going to be a positive 3. And there's a 1 here. So 1 times what is 1? That will be 1. And again, this is all set equal to 0. So now I can set each term equal to 0. So x is going to equal a negative 1/4 there. X plus 3. So x equals a negative 3. And that would be those two answers. All right, let's try this again, see how this works. All right, so I'm going to set up my little diamond here. So a times c is 6. The middle term's a negative 7. So now I'm going to have a negative 6 and a negative 1. That adds up to a negative 7, multiplies to give me 6. So 3 goes into 6. So 3x times x, that would give me my first term. And I know it's going to be 3x and x, first of all, because 3 is prime, but also because 3 goes into, it should go into one of these numbers in the side. All right, since it goes into the negative 6, I put a negative 6 here, and the other number goes here. So you ask yourself, 3 times what is negative 6? So that's a minus 2. And then 1 times what is a negative 1? So that's a minus 1. Notice a negative 1 times a negative 2 is a positive 2. You could FOIL this out, make sure it works if you're not sure. So that does work. So now I set each factor equal to 0. So x equals 1/3, and x minus 2 equals 0, x equals 2. So it's actually not that hard to factor something that has a coefficient other than 1. Now we have the difference of squares. Difference of squares is whenever you don't have that middle term. Notice that middle term is missing, and that's because it got added and subtracted away during the foiling process. So what a difference of squares does is it basically takes the square root of the first term and then the square root of the last term, and it joins them with a plus and a minus, something later on we'll call conjugates. So I come down here, I know the square root of 25 is 5, so this will factor into x plus 5, x minus 5. So when I go to solve it, my answer will be plus or minus that 5. That's as simple as that. And it's okay if you don't have a is 1. I don't know why I'm doing that. Let me retrace that. Don't need that. Okay. So we're going to take the square root of 25 and the square root of, so the square root of each term. So this will be 5 minus 3x and 5 plus 3x, because that middle term got added and subtracted away. So as we solve this, 5 minus 3x equals 0. We are going to get, I'll work it through. So we get that x is going to equal plus or minus 5/3. And that would come by setting each one of these factors equal to 0. 5 plus 3x equals 0, 5 equals negative 3x, and then divide. Okay? Now, factor by grouping, you're not going to get too much of this when we're solving the parallelogram problems, but it's a good review. Whenever you have 4 terms, this is my go-to method. Doesn't always work, but it's definitely a good start. And the idea is I'm going to group the first 2 and group the second 2, and I factor out what's common. So in these first 2, I have m squared that is common. So that leaves me with m plus 8, because it's like you're dividing each term by m squared. Then I'm going to factor out a negative 9. So factoring out that negative is going to change the middle sign here to a positive. 9 goes into 72 8 times. And so you know you've done it right when these 2 factors are identical. Because what I'm going to do now is I'm going to factor out that common m plus 8, and everything else goes into another parenthesis. But notice, so this was all, notice I have m squared minus 9, so I can keep factoring this. This turns into m plus 8, m plus 3, m minus 3. So my final answer here, which I've run out of room, is going to be m equals negative 8 and plus or minus 3 by setting all 3 factors. So notice I have 3 answers there because my highest degree now was 3. You always will have as many answers as your highest degree. All right, let's try that again. Let's start with, okay, we have here these 2 terms and these 2 terms. So I factor out my x squared, and that's going to leave me with x plus 3. And then I can factor out a 2, which leaves me with x plus 3. Again, we want to have those be the same. So now I'm going to factor those out. I have x plus 3, and then here's x squared plus 2. And when I set these equal to 0, this one will give me x equals negative 3. This one's going to give me no real solution, because I would have x squared equals a negative 2 if I start to solve that. And since we only want real solutions, we're just going to go with the negative 3. All right, let's say you're given something and it is not factorable. You try to do the little diamond method and it just doesn't work. Well, that's when you have to use the quadratic formula, which I have down here. And how would you know? So let's say, so remember the first thing you want to do is set this equal to 0. And if I try and do my diamond, so a negative 1 would be here and a negative 10. There's nothing times something that's going to give me 1, but add up to a negative 10. So that's how I know I'm going to have to use quadratic formula. So I know that A is 1, B is a negative 10, C is a negative 1 for what's going to go in the formula. I always like to do the discriminant first. That's this part underneath the radical, because it's the most intricate part of the formula. So if you can get that out of the way, everything else is just plugging stuff in. So this is going to give me b squared. So that's going to be 100 minus 4 times 1 times a negative 1. So 100 plus 4 is 104. So now I'm going to do the formula. So we have x equals opposite of b, which is 10, plus or minus radical 104. See, it's really nice. You just then plug it in, divided by 2. Now, if you are going to have to simplify this, what I recommend is you break it up into 2 fractions, because what people always forget to do is they forget to divide the second term here also by 2. So what does this give me? It gives me x equals 5 plus or minus, now 104, okay, let's take 104, kind of break it down. That's going to be 52 times 2, which is 26 times 2. And 26 can't be broken down into anything that's not prime. So these 2 2's are going to come out as a 2 rad 26, and that's still over 2. So your final answer is 5 plus or minus rad 26. All right, so we had to divide both terms by that 2, not just the first term, and that gives us our final answer. All right, well, good luck. Your homework is the back side of this worksheet.